Hi and welcome back to Technology Wizard. So today we're just going to do a brief tutorial on keyboard input, working with the CIA chip for the Commodore 64 machine language assembly, obviously. It's just going to be a quick one today, so we're going to be talking about input, so how to recognize key input on the keyboard map. So essentially what we've got here, we've got part of the bare bones already. So we've got our start address, we've got a basic stub that will jump straight into 2000, saves you having to type in the CS8192. And then I've already had these pre-made, so they're essentially little behaviors they do when you, so we're going to mask the F3 and the F5 key essentially. So these will start to become a bit more clearer once I start doing a few things. And the first thing we're going to do is create the movement label. So as we can see up there in CLS, we're jumping to movement afterwards. So, and in the movement label, we're going to load the accumulator with the value 0, 1. So essentially, if you've got the book mapping in the Commodore 64, this will make sense to you, or if you've ever done machine language assembly, this will all make sense to you. If it doesn't, I would suggest picking that book up, because inside that has a handy keyboard map for the CIA chip. So essentially, it'll lay it on a grid exactly where these keys are in the memory and how to poke them. So the first part that we're going to do is essentially setting the DD, so data directional register A. We're going to be setting that first. So the reason why we have to set that is because it's all good and well making sure that you've got the F3 key when you got the bits and you do what you need to do, but you need to tell it which bit are we focusing on here, and this is where this comes into play. So essentially what we're doing is, because F3 lives, just say we're watching the same thing together, it lives in bit 0, and bit 0 it has a hex value of 0, 1. So that's our hex value, and then we're going to store it in our data directional register. So this tells it bit 0 lives in this part of the memory map. So sorry if I'm not explaining it as well as I would like to, but then we'll store that in DC02. As you can see here, I've got a brief map from up here, so that's where we're storing it, and that's really essential before we do anything. Otherwise, you know, if you don't do this step, you can essentially hit the F3 key with completely opposite, so like the Commodore key. If you're looking at F1, you could also hit space, which is the bit 10, not bit 10, sorry, bit 4, which is hex value 10. That's the reason why we need to do this part here. Then we're going to start with the second part, which is essentially, bear with me, which is essentially what we're going to do now is tell it where we're going to store it. So from here, we've already done the data directional movement on it, and now we're going to figure out which bit holds F3, because that's the first one where we want to move up today. So F3 lives in bit 0. So what we're going to do is bit 0 is 0, 1 hex value. We're going to do a bit of calculation, and it's essentially 255, and then we take away 1, so that's 254. And now in hex, 255 is FF, and then 254 is FE. So that's what we're looking for now. So FE, we're going to load FE into our accumulator, and then we need to store that somewhere. So where we're going to store that is right here, and that's the CIA chip number 1 register 0. So we're essentially putting it into DC00, DC00, and that will cover the row of the map, essentially looking what row we're looking for. And once we've done that, we're now going to load another address, which is DC01. And then DC01, if we have a look back here, is CIA chip number 1, register 1. So essentially what that does, that looks at the column. So we feed it, look for, essentially saying to it, look for F3 in that row. And then we're saying here we're going to load the column value, and then we're going to perform an AND operation on the bit. So essentially what the bit we're looking for is bit 5, which is 20. So the hex value 20 will go in there. It essentially loads that, loads FE, which is the row, stores that into the 0, loads the register 1 within the CIA chip number 1, and then performs a bit value and operation against the value hex value 20, isolating, and what that will do is isolate F3. And then we're going to branch if equal. So if that does equal that, we're going to branch to the CLS. So that's where we're going to go. No, we'll go to CLS2. And then what we'll do is we'll jump back to the movement label. So that'll make it spin in a circle until it finds a value. And then we're going to come down here and we're going to create another one called movement 2. So this is where our other one will live. And then again we're going to isolate, we're looking for F5 now. We'll do F5, which lives in the same row. So we'll be looking FE, storing that into DC00. Before we do that, modify, bear with me. No, we should need to modify, storing that, loading that, which is in DC01, performing another AND operation, and this time we're looking for bit 6. So bit 6 is 40 in hex value. So we're going to be performing that, and then do another branch if equal. So this time, instead of moving to CLS2, we're going to go up to CLS, so our original address where we're starting from. So then we do that, and then as we did last time, we jump back to the movement 2 label. And if we've done everything correctly, which we should have, what they will essentially do is it's got that character up the top there, and then we know that it's moved down to the first part, which is looking for our F3, and it changes, and then we're looking for F5, and this is where we've learnt our first lesson, because we indeed do need to load 01 back in there. So because it's getting overwritten, we need to store that back in DC02. Now see if we get anywhere from this one. We should be good to go. And I've made my first or second mistake that I can see here. Won't even bother running that because we should be going to CLS, not CLS2. So that's the way it should go. We first open, we've got the character displayed and stored into that part of screen memory. So this is obviously the start of screen memory. Jumps down to movement, and it's asking for a key press. We find the F3. If it does equal F3, we come back up to this way. clears the memory, loads the uppercase K, which is a character, and stores it into 04, comes back down to movement 2, and then wants to keep going. So we should get what we originally planned on doing this time around. So as we've got here, and we have switch between the two characters. So this is obviously very basic. You can do this with sprites. If you create sprites, which will be another possible video I'll be uploading one day, you can do that with sprites as well to move it against the screen, decrementing the Y register, incrementing X register, etc. So you're playing with the X and Y axes, and that is the basics of it. So I'll explain everything up here just in case. So E544, that is the kernel routine to clear the screen. Nice and simple. You're loading, and it wouldn't work if I loaded a complete sentence, but you're loading just the string, the text string B, capital B, which is a character. You're storing it in 0400, which is the start of screen memory, and then we're jumping back to the movement label and doing it all again. So to run through our keyboard input again, we're loading 01 because that is the data directional port, and I'll show you what I mean by the data directional port. I'll bring that up on your side here. I'm just bringing that over. So this is what I mean by the data directional port. So that's the data directional port that we're working with. So that's where 0 comes into play. So we've got bit 0 is where F3 sits. We've got 01, and that's the reason why we have to store 01 in DC02, because you are isolating that. If we didn't do that, then as you can see up here, that key would do it. The same with F5. The Q key would make F5 go off as well, so that's why we're getting it down. And then you're loading FE, and then again, from the reason why we do that is we take 255, which is the complete value within a byte essentially, and then we're taking the 01 away, which is 254, which is FE. So that's why we're doing that. We're storing that into the first CIA chip, register 0, loading register 1, comparing essentially, not really comparing, but performing an AND operation, basically saying within there is the hex value 20, which is, you can't see it on the screen, but it is bit 5. Is bit 5 present, which is up here for F3, and then it essentially saying, yeah, it is present, I can see it. Cool, then let's go to CLS2, which it jumps up here and then performs what it needs to be done, moving back down here, doing the same thing with F5. That's the basics of it. I would suggest mapping the Commodore 64. It is very handy with some of the addresses that you can only find in that book. Or you can find them on the web, but it's just very painstaking. This book has got it all. I've got the physical one. That's because I like the physical copies. Doesn't mean you have to. It's widely available online. But that's the basics of it. So as you can see, works fine within itself. Like I said, you can do this with some snippets as well. You can do this with a lot of things. That sprites, I meant to say, sprites can be used like this as well, which is very handy. But I'll leave it at that. If you have any comments about this video or something you would like me to touch in the future, please let me know. If you liked what you saw, also let me know in the comments, and I hope to see you for more videos in the future. Thank you for watching.